Hello friends. Welcome to T Academy. Let's continue the questions of previous AW paper of 2024. Okay, and the question is from the control systems. A system has a open loop transfer function of g of s is equal to s plus 2 divided by s plus 1 into s minus 1. The number of encirclements of the Nyquist plot around -1 plus j0r. So here we need not need to find the stability, but just we need to find the number of encirclements. Okay, number of encirclements. General formula is the number of encirclements n is equal to p plus minus z plus. So where the p plus is nothing but number of poles of open loop transfer function, and z plus is nothing but it's the number of poles of closed loop poles of closed loop transfer function or characteristic equation, you can say. So to solve this problem, so we have to draw the first polar plot of this function g of s. Okay, and this question is a standard question. G of s is equal to s plus 2 divided by s plus 1 into s minus 1 here. So first step is put s is equal to j omega in that equation. Then g of j omega is equal to j omega plus 2 divided by j omega plus 1 and j omega minus 1 here. Okay, and if you observe this equation here, there is one pole which is lying on the RHS plane. So there is nothing but p plus. Okay, that is open loop transfer function poles which lying on the RHS plane here. So there is a one pole, that's a p plus, which is lying on the RHS plane here. Okay, now we'll write this equation here like this. And what about the magnitude of g of j omega? So magnitude of g of j omega is nothing but square root of omega square plus 4 divided by square root of omega square plus 1, and this one will be square root of omega square plus 1. Okay, so minus of 1 square is nothing but 1 square only. So this is the magnitude here. And what about the phase angle? So angle of g of j omega, which is equal to, so first tan inversion of omega by 2 minus tan inversion of omega by 1 and minus of pi minus tan inversion of omega by 1 here. Okay, so if you further simplify this is nothing but tan inversion of omega by 2 minus of tan inversion of omega and minus pi plus tan inversion of omega. So if you observe closely here, the minus tan inversion of omega gets cancelled with the tan inversion of omega here. So which is further written as here, so tan inversion of omega 2 minus pi. So this is the equation number 1, and this is the equation number 2. This is the magnitude plot and this is the phase angle plot here. Now we will take these two equations, but in examination point of view, no need to do this calculation. Simply if you are substituting omega equal to 0 and omega equal to infinity, those two numbers will be enough for us. But for your understanding point of view, I am breaking the table here with the help of a calculator. I am drawing. I'm using this one, and serial number will write, and you will take the w and the magnitude of the transfer function and the phase angle of transfer function. So first one is serial number 1. I'll take omega value is 0 and the magnitude will become 2 and the phase angle is minus 180. Okay, and similarly serial number 2 I'll take the omega value is 2 and it is magnitude is 0.57 and angle is minus 135. So similarly I'll take the omega value as a 10 and magnitude is 0.10, and the phase angle is minus 101.3 degrees. Okay, and the last value, if I tend to take omega value as infinity and magnitude becomes 0, phase angle becomes minus 90 degrees. So all the values which I got here, okay, so all the values which I got here, these values are from the equation number 1 and 2 here. For example, if omega equal to 0 here, what will happen? 0 square plus 4, that's what 4 root here, that is 2. 0 square plus 1 means 1, 0 square plus 1 means 1 only. Okay, at that time I got a magnitude of 2 here. And similarly, when omega equal to 0 here, so omega equal to 0, substitute here, what you will get in this case? So tan inversion of, okay, 0 minus pi. So tan inversion of 0 means it's a 0 only. 0 minus 180, which is nothing but minus 180 degrees. So that's what I have written here. Okay, so similarly, if you substitute omega equal to infinity, at that time the magnitude is going to be 0 and the phase angle is minus 90 degrees. Okay, so now we have to draw this GSWS plane here. Okay, GSWS plane. So GSW I'm drawing here, okay, like this. So this is GSW's plane, and 0 here we have minus 90, minus 180 and minus 270 degrees. Okay, now the given question is what they are asking. So they are asking the number of encirclements of the Nyquist plot around minus 1 plus j0. Okay, so let me take here, let me assume that this is a minus 1 plus j0 point here, minus 1 plus j0 point here. Okay, now with respect to omega, when it is a 0, the value is minus 180. So I'll take some other color of pen here, so that okay, right here. So here it's a, let me take, this is the value of 2 here. So when omega is 0, so at this time omega equal to 0, the magnitude is 2 and the phase angle is minus 180. And similarly I'll take the last one here. When omega equal to infinity, the magnitude is 0 here. Okay, 0, and the angle here it is 90 degrees. So 90 degrees here. And what about the direction of this polar plot? So it is given by phi 1 minus phi 2. So what's the phi 1 value? Minus 180 minus of minus 90, which is nothing but minus 180 plus 90, which is equal to minus 90. Minus indicates that it is a counterclockwise direction. Okay, so counterclockwise direction means, that means the values of this graph will be like this. So it is in the counterclockwise direction. And if we draw the Nyquist plot here, that is exact mirror image of this, will be like this. Okay, now see here how many times this minus 1 plus j0 point is encircled. So if you observe here, there is a only one encirclement. Okay, that means the answer will be n is equal to 1 here. Now check the stability point of view, right? So n is equal to, so p plus minus z plus here. So we know that encirclement is 1, and p plus, already we discussed that p plus is how much? It is a 1. So p plus is also 1 minus, we don't know about the z plus. So simply see here, what is the z plus? Z plus is equal to 0. That means there are no closed loop poles lying on the RHS of the plane. Then we can say the system is also a stable system. The system is a stable system here. Okay, so the conclusion we can see here is, when you are seeing the open loop transfer function, this transfer function g of s is nothing but it's a simply unstable system. When you are taking the closed loop system, then it become a stable system. Okay, stable system here. So the answer for this question is 1, counterclockwise, or we can say anti-clockwise direction. Okay, anti-clockwise direction. there is a one encirclement here like this. Okay, so that's it in this session. We'll continue with the other question in the next video. Thank you friends, have a nice day.